Hello everyone, welcome back to the Atharva Academy. In this video, we are going to see some more example based on shear force diagram and bending moment diagram. So let us see example 11. In this example, here there is a beam of length L. In this example, there is a beam AB of length L and which is fixed at the right end. Here there is a point C at the distance of A from point A, and we apply uniform distributed load W in the downward direction between point A and C. To finding out shear force and bending moment in this example, we will take two intervals. First interval will be 0 less than or equal to x less than or equal to A. Here we will also consider point C, so there will be a less than or equal to sign here. Now to find out value of shear force in this interval, we will take a section between this interval. This section is at the distance of x from point A. Now if you want to find the value of shear force at this section, then we have to take sum of all the transverse force acting at the left side of this section. And here there is a uniform distributed load W acting at the left side of this section. So what will be the value of shear force? Shear force will be equal to minus W into X. This is the total load applied by this uniform distributed load, and it is in the downward direction, so it is negative. Now we will find bending moment M in this interval. For that we will take integration of shear force. So it will be integration of F. So it will be equal to integration of minus Wx is equal to minus W x square by 2 plus C. Correct? Now we know that at point A, value of bending moment will be 0. So at x is equal to 0, M will be equal to 0. So finally value of C will be 0. So M will be equal to minus W x square by 2. From here, what will be the value of shear force at point A? At point A, x is equal to 0, and if we put x is equal to 0 here, then shear force will be 0. And from here, what will be the value of shear force at point C? At point C, value of x is A. So we will put A instead of x. So it will be minus WA. Now from here, what will be the bending moment at point A? For that we will put x is equal to 0. So it will be 0. And from here, bending moment at point C will be minus WA square divided by 2, because we put x is equal to A. Now let us draw shear force and bending moment diagram for this interval. So here there is a point A, here there is a point C, and here there is a point B. And similarly here it is point A, it is point C, and it is a point B. This direction is x direction. In this direction, here there is shear force F, and here there is a bending moment M. Now here you can see that shear force is the equation of line, because here the power of x is 1, right? So to draw the shear force diagram in this interval, we need 2 points, and then we will join that 2 points by line. So here we have that 2 value. At the point A, value of shear force is 0. So here we have this point, and at point C, value of shear force is minus WA. So at this point, it will be in this direction, because it is negative, let's say somewhere here. And here this distance is minus WA. So we will join these 2 points by a straight line. Now we will draw a bending moment diagram in this interval. Here you can see that equation of bending moment diagram is having power of x 2. So this is the equation of parabola. And to draw parabola, first we will need 2 points. Here we have this 2 value, and we are going to put this value in this diagram. at x is equal to a, value of bending moment is 0. So here we get this point, and at x is equal to c, value of bending moment is minus w a square by 2. So at this point, bending moment will be somewhere here. Now we have this 2 point, and we have to join this 2 point by parabola. And to draw parabola, we need the direction of curvature. Either it will be in downward direction or it will be in upward direction. For that, we will take double differentiation of bending moment. And here if we will take double differentiation of this bending moment, then we will have finally a negative value. So that we can say that the curvature of parabola will be in downward direction. So it will be something like this. And here this distance is minus w a square by 2. Okay. Now we are going to see the value of shear force and bending moment diagram in this second interval. And the second interval is a less than or equal to x less than or equal to L. In this interval, what is the value of shear force F? For that, we will take section between this interval, which is at the distance of x from point A. To find the value of shear force at this section, we will take sum of all the transverse force acting at the left side of this section. And here there is a uniform distributed load acting in the distance A from point A to C. And what will be the total load by this uniform distributed load? It will be the value of this load into this distance. And it is in the downward direction, so we will take it negative. So it will be equal to minus WA. Correct? Now we will find bending moment in this interval. It will be equal to integration of shear force is equal to integration of minus WA into dx. Here we put F is equal to minus WA. Therefore, M is equal to minus WAX plus C. Correct? To find out value of C, we need to put the boundary condition in this equation. Now we know that at point C, the value of bending moment is minus WA square by 2. And at point C, value of X is A. So we will put X is equal to A here and bending moment minus WA square by 2 here. So it will be minus WA square by 2 is equal to minus WA into X is equal to A. So it will be A square plus C. From here, value of C will be equal to WA square by 2. Now we will put value of C here. So it will be plus WA square by 2. Okay. Now from here we will find value of bending moment at point B. For that we will put X is equal to L. So it will be equal to minus WAL plus WA square by 2. And if you simplify this, then you will get WA by 2 into bracket A minus 2L. So now we are going to draw the shear force diagram and bending moment diagram in this second interval. Now you can see that value of shear force is minus WA, which does not depend on X. So the value of shear force will be constant in this interval. So here it will be a horizontal line parallel to the X direction from this point to this point. We know that there will be a reaction at point B like this, and there will also be a reactive moment at point B like this. So this point load will give sudden effect on shear force diagram at here. So it will be a vertical line joining these 2 points. Now we are going to draw bending moment diagram in this second interval here. Here you can see that this is the equation of bending moment, and here in this equation degree of x is 1. So this is the equation of line. To draw that line, we need 2 points, and finally we will join that 2 points by a straight line. Now here we already have one point, this. At x is equal to c, value of bending moment is minus wa square by 2. At point B, x is equal to L, and bending moment is wa by 2 into bracket a minus 2L. Here value of L is greater than a, so this moment also will be negative. So it will be below this axis somewhere here. And finally we will join these 2 points by a straight line. And also there is a reactive moment at the point B, which is a concentrated moment. And we know that concentrated moment gives sudden effect on bending moment diagram. So it will be a straight line joining these 2 points like this. I hope that now you are getting the idea that how to draw shear force diagram and bending moment diagram. Correct? Now we are going to solve the second example. In this example, there is a beam AB of length L which is simply supported. Means you can understand like this. This is a beam. One side it having hinge support and second side it is having a roller support. We apply point load P at the middle of this beam. Because of that, there will be a 2 reaction at the end, and that I have drawn here. Okay? Now in this example, I apply this P load at the middle of this beam. Because of that, the value of reaction at point A and B is equal. Then to finding out reaction, we have to take moment about point A or moment about point B, and we also have to take that summation of force in vertical direction is equal to 0. Right now we are going to discuss this example. In this example, we apply point load P at the middle of this beam AB, which is having length L. It will be a point load and it will be in the vertical direction, having value P by 2, P by 2. Now we want to draw the shear force diagram and bending moment diagram for this case. For that, we will take interval AC, 0 less than or equal to x less than or equal to L by 2. Now in this interval, we will take a section at the distance of x from point A. And at this section, we want to find out value of shear force. For that, we will take sum of all the transverse force acting at the left side of this section. Now here you can see there is a load P by 2 which is acting in the upward direction at point A, and it is in the upward direction, so we will take it positive. So value of shear force F will be equal to positive P by 2. Now we want to find out bending moment at this section. We know that bending moment M is equal to integration of shear force. Here we can put value of F from here and find out bending moment. But right now we can directly find out bending moment, that is load into distance. So here bending moment M will be equal to load, that is P by 2, and distance from this section is x, so into x. If you use this equation, then you will also get this bending moment. Now we are going to draw shear force diagram and bending moment diagram for this interval. Let's say this direction is x direction and here it is also x direction. In this direction we will take value of shear force F, and in this direction here we will take bending moment M. This point is point A, this point is point C, and this point is point B. Similarly here, this is point A, this is the point C, and this is the point B. Now understand carefully that here there is a point load P by 2 at point A, and we know that point load gives sudden effect on shear force diagram. So there will be a vertical line like this at point A, and here this distance will be P by 2, because here the value of load is P by 2. Now in the interval of AC, value of shear force F is plus P by 2. So if we draw shear force diagram in this interval here, then it will be a horizontal line parallel to the x direction from point A to point C. And at point C we apply a point load P in the downward direction. And again this point load is going to give the sudden effect on this shear force diagram. So it will be a vertical line at point C like this. Here this distance is P by 2 and here our value of load is P. So here this whole distance will be P. So this distance will be P by 2. Okay. Now let us draw the bending moment in this interval. In this interval, value of bending moment M is P by 2 into x. Here the power of x is 1. So this is the equation of line. And to draw the line we require 2 points. First we will put x is equal to 0. So we will get bending moment at point A. So from here bending moment M at point A will be 0. And now we will put x is equal to L by 2. So that we will get bending moment at point C. And if we put L by 2 here, then the value of bending moment will be PL divided by 4. Correct? Now we have 2 points. At x is equal to 0, value of bending moment is 0. So we have this point where x is equal to 0 and M is equal to 0. And at x is equal to L by 2, value of bending moment is PL by 4. So here there is a point C where x is equal to L by 2. And here value of bending moment is PL by 4. So let's say this is the point and this distance is PL by 4. Now we have to join these 2 points by a straight line like this. So this will be the bending moment diagram in this interval. Now we are going to find value of shear force and bending moment in this second interval. That is L by 2 less than or equal to x less than or equal to L. In this interval we have to find out value of shear force F. For that we will take a section in this interval at the distance of x from point A. Now to find out value of shear force at this section, we have to take sum of all the transverse force acting at the left side of this section. Now here you can see that there are 2 transverse force acting at the left side of this section. That is P by 2 in upward direction and load P in the downward direction. This P by 2 load is in upward direction, so we will take it positive. And here this P load is in downward direction, so we will take it negative. So finally value of shear force will be minus P by 2. Now we are going to find value of bending moment. For that we will take integration of F. So it will be integration of minus P by 2 into dx. So it will be equal to minus Px by 2 plus C. Now here we have to find out value of C. For that we will put a boundary condition. And we know that bending moment at point C is PL by 4. And at point C value of x is L by 2. So if we put here M is equal to PL by 4 and x is equal to L by 2, we will get value of C is equal to PL by 2. So finally our bending moment M will be equal to minus Px by 2 plus C is equal to PL by 2. So it will be PL by 2. Now we are going to draw the shear force diagram and bending moment diagram in interval CB. In this interval value of shear force F is minus P by 2, which is constant in the interval. So it will be a horizontal line parallel to the x direction from point C to point B like this. And here this distance is P by 2. Now here this distance is P by 2, but it is in the negative direction. So at this point value of shear force will be minus P by 2. And here you can see at point B there is a point load P by 2 in vertical direction. So it will give sudden effect on shear force diagram at this point. So it will be a vertical line joining these 2 point. Here this black line shows the shear force diagram for this example. Now we are going to draw bending moment diagram in this second interval. In this second interval, value of bending moment M is minus px by 2 plus pl by 2. Here you can see that the power of x is 1. So this is the equation of line. And to draw line, we need 2 points. First point will be at point C. At point C, value of bending moment is PL by 4. That is this point. And at point B, x will be equal to L. And if we put L instead of x here, then value of bending moment M at point B will be equal to 0. Because here minus PL by 2 plus PL by 2 will be equal to 0. So we will get this point. Now we will join these 2 points by a straight line. And this black line shows the bending moment diagram for this example. Now let us discuss this another example. In this example, there is a beam AB of length L, which is simply supported at point A and point B. There is a uniform distributed load W over this beam. In this example, we will draw shear force diagram and bending moment diagram, and we will also find value of bending moment at point C, which is at the distance of L by 2 from point A. Now this is the beam which is simply supported and over which we apply uniform distributed load like this. The value of this uniform distributed load is W. If we apply uniform distributed load like this in the downward direction, then there will be a reaction at this both end like this. Now what will be the total load due to this uniform distributed load? The total load, capital W, will be equal to small w into L that we have discussed earlier. So it will be the total load acting on this beam. Now this load is acting uniformly throughout the beam. So the reaction at both the end will be same and it will be half of this total load. So we will get WL by 2 reaction here and WL by 2 reaction here that I have shown here. Now here there is no any other load acting between point A and B. So we will take interval between A and B, that will be 0 less than or equal to x less than or equal to L. Now in this interval we want to find out value of shear force F. For that we will take a section between point A and B, which is at the distance of x from point A. Now to find out value of shear force at this section, we have to take sum of all the transverse force acting at the left side of this section. Now at the left side of this section there are two loads. One is this reaction, which is a point load, and second one is this uniform distributed load over length of x. Now here this point load is in upward direction, so it will be positive WL by 2, and here this uniform distributed load is in the downward direction, so it will be minus, and the load due to this uniform distributed load over x length will be W into x. Correct? Because total load is equal to value of uniform distributed load into the distance over which load is applied, that is x. Now what will be the value of bending moment in this interval? It will be the integration of shear force. So what will be the integration of shear force? Here I am directly going to write down the integration of this F. It will be equal to WL by 2 into x minus W x square by 2 plus there will be a constant C. to find out value of constant c, we will put a boundary condition. And we know that the value of bending moment at the point A will be 0. Because at point A, there is no any bending moment applied like this. Yes, there is a point load WL by 2 acting on the point A, but the distance between point A and the point of application of this load is 0. So finally the bending moment will be 0. So if we put m is equal to 0 at x is equal to 0, then we will get value of c is equal to 0. So finally our bending moment m will be WL by 2 x minus WX square by 2, and it will be 0. Now we are going to draw the shear force diagram here and bending moment diagram here. Here our this direction is x direction, and in this direction we will take shear force, and here we will take bending moment. We will take 3 point A, C and B. Here also we will take this 3 point. First of all, we will draw shear force diagram in this interval, means between point A and B. Here the equation of shear force diagram is this, and here you can see that the power of x is 1. So this is the equation of line. So again we will take 2 points, and finally we will join that 2 points by a straight line. First of all, we will put x is equal to 0. If we put x is equal to 0, then we will get shear force at point A. If we put 0 here, then this term will be 0 and we will have WL by 2. So it will be WL by 2. And if we put x is equal to L here, then we will get shear force at point B. So if we put L here, then it will be WL by 2 minus WL. So finally shear force at B will be minus WL by 2. Correct? Now we are going to mark this 2 point here. Shear force at point A is WL by 2. Means at this point value of shear force is WL by 2. So let's say it is somewhere here. And at point B value of shear force is minus WL by 2. So let's say at this point it is somewhere here because it is negative. And now we are going to join this 2 point by a straight line. So it will be like this. Now here you can see that at point A there is a point load acting in the upward direction having value WL by 2. And we know that point load have sudden effect on shear force diagram. So it will be like this. A vertical line of distance WL by 2. Here this point is having value WL by 2. Correct? And at this point you can see that there is a point load acting having value WL by 2 in upward direction. So here also there will be a sudden effect on shear force diagram. So it will be a line joining this 2 point. And here this point is having shear force value minus WL by 2, and this distance is WL by 2. Correct? Here this blue line shows the shear force diagram for this example. Now we are going to draw the bending moment diagram for this example. The equation of bending moment is here, and in this equation maximum power of x is 2. So this equation is the equation of parabola curve. Now first of all let us put x is equal to 0. So we will get bending moment at point A. If we put x is equal to 0 here, then we will get bending moment at A as 0. Now we will put x is equal to L. So we will get bending moment at point B. So bending moment at point B will be WL by 2. Instead of x we will put L, then there will be a square of L. Minus, if we put L here, then it will be WL square by 2. So finally it will be also 0. So we will get 2 points. One point will be at here and second point will be here. Now let's say we want to find out bending moment at point C. For that, we will put x is equal to L by 2 in the equation of bending moment. So it will be m is equal to WL by 2 into L by 2 minus W into L by 2 square divided by 2. If you simplify this, then it will be WL square by 8. Correct? So here, this is the point C, and at point C value of bending moment is positive WL square by 8. So let's say it is somewhere here. Now we have this 3 point, and we know that this equation of bending moment is parabola. So it will be a parabolic curve joining this 3 point. Like this. I take the curvature of this bending moment diagram in the downward direction, because if we take the double differentiation of this equation of bending moment, means if we will take d square m by dx square, and if you find it, then it will be negative. So that here the curvature of this curve is in the downward direction. So I hope you understand that how to draw shear force diagram and bending moment diagram. We will also see few examples in next video. We will stop here for now and continue in the next video. Till then, practice the examples and try to understand the method. Thank you for watching.